what do you say? What's the question of the day? I'm Professor Q. So glad to be with you. So, as you see, that I'm in a whole new wardrobe. Can you guess what we're going to be talking about today? Space. That's right. Even more so about the lunar cycle. So, I have a question for you. What crater on the moon holds ice that's located on the southern side? So, did you figure it out? Which particular crater holds ice on the southern part of the moon? It's Shackleton Crater. Can you imagine that in 2024, NASA is getting ready to actually host the first woman and man to land back on the moon? How awesome is that? That's out of this world. Literally. So, well, I have another question for you about the specialty of the moon, because the moon is our particular neighboring entity that we get to see on a daily basis at night and sometimes during the day as well. The question is, does the moon have an atmosphere? Does Earth have an atmosphere? I hope so. But does the moon? Well, a lot of individuals will think, no, it doesn't have an atmosphere, but it does. It has a very thin atmosphere called an exosphere. So, something new to learn today, isn't it? Wonderful. Well, it's very important that we understand how we are around moving within this solar system of ours. And one particular way to say is that, well, Earth, as we have a model here, is actually on its axis in a tilt. Now, when I have the ability to spin or turn the Earth, what am I actually doing? What is the Earth doing? It is rotating. That's right, it is rotating. Rotation and revolution are two important language terminologies that you must understand in order to have a grasp on this concept. So, as we have here, this is called rotation. But what is revolution? Well, we are here out in space, just wandering around on an elliptical orbit. But does the Earth rotate and revolve at the same time? I hope we do. Because revolution means to revolve around. Now, what is in the middle of our solar system? It's the sun. That's correct, our primary source of energy. So as the Earth is rotating, it's also spinning around the sun. Isn't that wonderful? Well, so if the Earth is rotating and revolving, my question is, what is the moon doing? Well, let's talk a little bit about the moon. Another word is called lunar. So how many of you have the opportunity to see all the different types of phases that this moon goes through? How many days does it take for the whole lunar cycle to happen? Go ahead and write that down now. It takes about 29 and a half days for the moon to go through its phase cycle. So, what type of phases have you seen before? Well, let's talk about 4 of the main phases that kindergarten through 2nd grade students would have a pretty good grasp on and looking at the objects in the sky. So, one of the most prevalent objects that we see is when the moon is full. That's right. So, looking at this particular diagram, we have 8 sections that are here. Which section do you think you would find the full moon? Did you say number 1? Good try. Let's try again. Number 5. Let's check it out. Oh, I need my special star. You're right. It is the full moon. Wow. Now, looking at this diagram, we see that which side is the sun going to be located? The sun is going to be on this side where it's represented by the orange. Now the question is, well, how is it that this can be a full moon when the planet Earth is in front of the full moon? Isn't that kind of like a linebacker blocking? Well, that's a good question. Or a basketball defender blocking? Is the Earth blocking the sun rays from the full moon? So I'd like for you to make this prediction now. What causes the full moon to be full? Okay, so the question was, how can a full moon be a full moon when Earth is blocking it? Well, it has to do with the relationships of how light rays reflect and refract. So all of the arrows of light rays don't just come linear, but they are bouncing all over. And so when the sunlight rays bounce off to Earth, does Earth capture all of the sun? No! A lot of those rays bounce off of, reflect off of, refract off of the Earth's atmosphere. And guess what just happens to be in its orbit and rotation to catch the light of where we see it from here on Earth up in the sky? It's the moon. And so in its particular orbit with that, the full moon then is viewed as fully lit. Isn't that amazing? So then my other question is, well, what is it when you can't see a moon at all? Have you ever seen that? Trying to look up in the sky, maybe use your GPS signal, Google Earth. Remember, it's Google Earth, looking for the Earth. So with that, well, what is that phase? And where would it be located? So between numbers 1, 3, and 7, which do you predict would be the moon that you cannot see? Right, it's actually number 1. That's called the new moon, where you're not able to see it in its phase in the sky. It's completely dark. It's camouflaged in because of how that orbit is. So now we have a new moon and a full moon. But you ask, well, why is it a new moon? Why isn't it that we can see a full moon on the one side of us, but yet the other side we cannot? So I'd like a good question to be able to answer that. So I want you to think that we have our sun at this point. And so this moon is spherical. It's round, just like this Earth that we're on. And so what happens is that this particular moon phase is when we are looking here on Earth towards that moon phase, it kind of blocks the sun's light from us being able to see. And so what happens is that on one side of the moon, we're seeing completely nothing, and on the other side is brighter light, just because of its orbit. Isn't that fascinating? So then if we have a new moon, and on the opposite side we have a full moon. And mind you though, during this full moon, that moon phase is not there. We got a big star. So then what would be between 3 and 7? What do we call those? Well, let's take a look at number 3. It's called our first quarter. Well, what would that be? Can you make an observation? That's right. That half is white and half is dark. Excellent observation, little Gray. Very good. So we have our other guest, special guest as well, trying to help us out. So with the first quarter, what's happening is that which side is the light, white, bright on? Which side is it? Yes, it's on the right-hand side. Very good. Exactly. So I want you to think of this. How can we make sure that is? Well, which side is the sunlight coming from? It's on the right. So the light is on the right. I say light on the right. So you say light on the right. You ready? Light on the right. And as you see, because the sun is on the right, this on the moon, the light will be on the right. The sun rays are coming in. Well, then the question is, we have a new moon, we have a first quarter, and a full moon. So, my goodness, what would be number 7? Can you make that prediction? What do you think, little Gray? I think, well, let's try it, shall we? Number 7 is the third quarter. That's right. Excellent job. But wait a minute. First quarter, third quarter. Can you make an observation of how it's shaded in? Good observation that the third quarter is actually a mirror reflection of that of the first quarter. I wonder why. Well, also, we'll get to that momentarily. I want you to think about, well, we have new moon, first, full moon, and third quarter. Think of it like a basketball game. How many quarters are in a basketball game? 4. How many quarters are in a football game? 4. So we have really 4 main phases, 1, 2, 3, and 4, to help you remember. So for kinder through second grade, this is the types of lunar phases the students will need to understand. But now, let's say you've graduated, and we're now moving up a little bit more. So the question is, well, what is 2, 4, 6, 8? Who do we appreciate? Woo-hoo! All right, so we appreciate the astronauts and NASA and space. Absolutely, because where would we be? Quick trivia question. We just celebrated last year the 50th anniversary of Apollo 11 landing. So what year did it actually land on the moon? Did you say 1969? You're correct. Actually, July 20th, 1969 was that specific date when we landed 2 men on the moon. Houston, we have a problem. I hope not. So, let's get back to our learning, shall we? 2, 4, 6, 8. Well, what does 2, 4, 6, 8 represent overall? Well, we have a new moon going to a first quarter. So there's something that has to be in the middle. Can you figure out what that's called? What is the name of that moon phase? It's a waxing crescent. Absolutely. So do you see how that there is, the light is on the right? And what's happening? Going from you can't see the moon at all to it's kind of like a croissant or a banana or a thumbnail. Call it whatever you'd like to see it. However, it's called a waxing crescent. And then there's many other phases of the waxing crescent as it eventually gets to the first quarter. Now, once we get to the first quarter, what do you think number 4 would be? Because we're going from an all dark to an all light. What do you think? I think you're right. It's a waxing gibbous. Correct. So you see that the dark, the shadow is starting to slowly fade away. So that way there's the full moon. Excuse me, a little stardust. So can you observe here, what are some commonalities? Good this time. And please, try to find two commonalities or observations from going from a new moon to a full moon. So, did you find out at least two observations from going from a new moon to a full moon? Well, one observation is the fact that we have waxing as part of the title. Absolutely. So when you wax a car, does it get dirtier or shinier and brighter? It gets shinier and brighter, right? So that's one way to think about it, is that the waxing phase gets brighter and shinier. Absolutely. And you could have noticed that this is a crescent and this is a gibbous. Say gibbous. Now, what I'd like for you to do is write out the word gibbous. G-I-B-B-O-U-S. G-I-B-B-O-U-S. And then please write and draw a square around G-I-B. Are you ready? Kind of sounds odd a bit, doesn't it? Now, spell G-I-B backwards. What does it spell? Big! Because gib is big. I say gib, you say big. Gib, gib, gib. That's right. That's a strategy to help students learn that gib is, you're going to see the biggest part of the moon. Whether it be in the waxing phase or another type of phase we're just about to get to now. Good observations. So, we have the new moon to the full moon. Now, what do you think would be between 6 and 8? Well, let's talk about 6, shall we? Okay, we have a waning gibbous. Ah, there's that word again. I say gib, you say big. Gib, gib, gib. All right. So, as you notice, though, that this is a mirror reflection of this phase from the waxing. Now it's the waning. Have you ever heard of the word waning? And what does that word mean? Waning means getting smaller, kind of like saying goodbye. It's getting smaller, smaller, smaller. It's going away. So, what's going away? Well, the brighter light of the full moon is starting to slowly go away in the phase. And as you see, it will then transition to the third quarter. So what can you predict to be number 8? That's just awfully great. You're right. It's a waning crescent. Well, and what do you observe about the shape of that waning crescent? That actually it's starting to get darker, correct? And so now we have pretty much our full cycle of a lunar phase. Isn't that wonderful? So we have our waxing gibbous, waxing crescent. We have our waning gibbous and waning crescent. So if I were to say that the first part of this lunar phase takes time, but how much time? When would you expect to see the new moon, then eventually go to a full moon? So just for the sake of conversation, let's say, that the cycle lasts about 28 days. We know it's a little bit more. But if we were to dissect this in half into quarters, nicely, then we could say that from the new moon to the first quarter would be 7 days. And from the first quarter to the full moon would be another 7 days. So a total from going from a new moon to a full moon is how many days? 14! And how many weeks is that? 2. Correct. So then can we make that same assumption from going from a full moon to a new moon? You bet. So I would like to challenge you that take today's date and pretend that it's a new moon and fast forward how many days that you would see a full moon. Write that down now, please, on your calendar date. And then I challenge challenge you, when is the next time that you might see a third quarter? So if today was a full moon, approximately at what date of the month would you see the third quarter? Oh, y'all are so smart, absolutely. Okay, so I think we feel pretty confident thus far, right? And it's always great because you can always practice your phases. How, Professor Q? Look up to see the sky. Absolutely. So I have one more little quiz for you. I have my moon here. I just love it, absolutely. And I'd like for you to see what you can name the types of phases when you see them on the moon. Are you ready? Here we go. Ooh, what is that? Did you say that's actually resembles that of the waxing crescent? You're correct. What about this one? Oh my goodness. It's another transition of that waxing crescent getting bigger, lighter, and brighter. What does this resemble? It's your first quarter, correct. Oh my goodness. It's a waxing gibbous. And ultimately, we're going to have our full moon. Overall, the whole moon is full, reflecting and refracting that light. So then what happens as we come back? Well, we have a waning gibbous. You see that's all bright light, a little bit darker over on this side. Still a waning gibbous, not quite third quarter, but there's the third quarter. Moving on, we have a waning crescent, more waning crescent, and ta-da! We have a new moon. How cool is that? Well, class, it has been wonderful to be able to have conversations with you about space and the importance of the moon. And I'm going to leave you this. What an impact does the moon have on Earth? What impact does the moon have on Earth? Did you find out that answer of how the moon affects Earth? I have one clue for you. It has to do with the ocean. Okay, so thank you so much. Be strong and remember, good, better, best. Never let it rest till the good gets better and the better gets best. And if you would like to see more of Professor Q, please like, subscribe, and turn on the notifications.